Is the first part of topic 4. Topic 4 is all about reactions, and acid-base reactions is where we start. So let's get going. Acids, just a quick review. They ionize in aqueous solutions to form hydrogen ions. You need to memorize your 7 strong acids, and they are come on, hydrochloric, sulfuric, although only the first hydrogen here completely ionizes. Wrong one. Chloric acid, perchloric acid, nitric acid. Let's see, 1, 2, 3, 4, 5. Hydrobromic acid, and hydroiodic acid. These are the 7 strong acids that completely ionize. You will never write the complete formula for these compounds if they are aqueous. If they are solid or a gas, then you will write them together. But if they are aqueous, if you see a little AQ after them, then you actually don't write them as like HCl. You would write it as hydrogen ions and chlorine ions. If you have forgotten, need a memory refresher, or just need to flat out learn how to do the whole ionic stuff, ionic equations, net ionic equations, I've got a couple videos, the net ionics part 1 and part 2, that you'll probably want to watch to refresh your memory on how to do this. All the other acids are weak, and you would write as a complete formula, like acetic acid, CH3COOH, or phosphoric acid, H3PO4. These guys are weak acids, so you would always write these guys as the complete formula and not ionize them, because they don't ionize enough to actually count. Bases are substances that react with hydrogen ions. You need to memorize the 8 strong bases, and the 8 strong bases are all of the hydroxides from group 1, so like sodium hydroxide, potassium hydroxide, you know, stuff like that. All of the group 1 hydroxides, and all of the heavy group 2, calcium and below. So like magnesium hydroxide is a weak base, and so you would not completely ionize it, but calcium hydroxide is strong, and you would. So these guys you would actually write as like calcium ion and 2 hydroxides, as opposed to putting it together like this, unless of course it told you in the question, or you know, in real life you were actually using the solid version of this, and then you would keep it together. You only ionize aqueous compounds that are ionic. If it's not aqueous, you don't ionize it. So if you're told that it is a solid, a liquid, or a gas, or you are in a lab and you are using a solid, a liquid, or a gas, then you do not ionize it. You keep it together. It can only ionize if it's dissolved in water. So, neutralization occurs anytime you have an acid plus a base, giving you some kind of salt, and usually water, not always. Whenever you have a strong acid and a strong base, the anion in the acid becomes what's called a spectator ion. Again, watch the net ionic equation video if you need a refresher on that. The cation in the base is a spectator ion, so that all cancels out, and all you have left with is the ionization formula for water. There are some really strange acid-base reactions. The first one is when, in addition to a water and a salt, you make a gas as well. Anytime you see that a compound contains a carbonate, you're going to make CO2 as an additional product. Anytime you see that you have a sulfite, you're going to make SO2 as an additional product. And if you have sulfide ions in there, then you're going to make hydrogen sulfide gas, which these are just yummy smelling, let me tell you. So let me show you an example. Let's say you had sodium hydrogen sulfide, and you reacted it with an acid, so let's just do hydrochloric. You are going to produce the typical acid-base reaction product, so you're going to get water and a salt. The salt is still going to be the cation from the base and the anion from the acid, so NaCl. And you're also going to get, because you have a sulfite right here, you're also going to get sulfur dioxide gas. Of course, you would need to ionize this guy, so you wouldn't actually write him as HCl. You would write him as H plus and Cl minus. And because sodium chloride is a soluble salt, you wouldn't write him as that. You would write him as sodium and chlorine, which means your chlorines are spectators, so they cancel out. So your overall reaction is just the sodium hydrogen sulfide plus hydrogen ions gives you water, sodium ions, and sulfur dioxide gas that would bubble out of the reaction and just stink up your whole lab. So let's say we had the hydrogen sulfide. We had a sulfide compound. Let's just stick with sodium. So we got sodium sulfide, solid. We're going to react it with, let's say, some more hydrogen or hydrochloric acid. So HCl. You're going to produce, obviously you got sodium and you have chlorine, so you're going to make that sodium chloride again. Sodium chloride. And then your other product, because we don't have any oxygens over here, we can't make water. And so the only other thing we have is hydrogen and sulfur, hydrogen sulfide gas. Chlorines cancel out again as spectators, and there's your overall reaction. So just recognize that whenever you have these polyatomic ions or this element in a compound, you're going to get a gas in addition to the salt and or water that you would produce from a typical acid-base reaction. Then you have, what if you don't have a typical acid or a typical base? Well, if you have a non-metal oxide, these guys behave acidically, I guess. They behave like acids. And so if you react them with a base, you're still going to get a salt plus water. Same thing down here. Metal oxides behave like bases do. And so if you react them with an acid, you're going to get a salt plus water. And the way that you can remember this, if you can't remember, oh, are non-metal oxides acidic or basic, add a water to them and see what happens. If you put the two of these guys together, you get H3SO3. This is sulfurous acid. So non-metal oxides are acids. Down here, do the same thing. Add an H2O. You have Na2O2H2. Reduce out your 2's and you have NaOH, a base. So if you ever forget what non-metal oxides are or what metal oxides are, just plop a water onto them and it'll help you remember what it is that you're supposed to do. Now, what if you have a non-metal oxide and a metal oxide? Well, do the same thing. Plop a water on each one. You're going to get a water out of the other side so you can cancel, the waters out that you added on, and you're able to predict your product. If you don't have hydrogen over here, you can't make water over here. So really all that's going to happen is these two guys come together to just make the salt. So we're going to practice with these 6 reactions. I'll get as many of them as I can on this video, and then I'll probably have to make a part 2, and that's okay. I'm going to go through these really fast, so you probably want to pause them, try to work them out on your own, and then watch me work through them. I'm going to do both the ionic and then the net ionic equation on each of them. So here we go. Gaseous hydrogen chloride, HCl, we keep it together because it's a gas, is bubbled through a solution of sodium hydroxide. Solution of means that it's aqueous, so we ionize sodium hydroxide because it is a strong base. Right here I see, hey, once this guy hits water, it's going to turn into hydrochloric acid. This is a base, so react the two of them. We're going to get sodium chloride, which is a soluble salt, and OH plus H, water. Cross out my spectators. My overall reaction that I would write in the little box on question number 4 is HCl plus OH minus yields Cl minus plus H2O. Double check to make sure it's balanced. We're good. We can move on. There would be a question that you would have to answer about this, but right now we're just working on the equation itself. Okay, aqueous potassium hydroxide is mixed with a solution of acetic acid. Potassium hydroxide is a strong base. It's aqueous, so we ionize it into potassium and hydroxide, is mixed with a solution of, so aqueous, acetic acid, but acetic acid is a weak acid, so we can just write it, CH3COOH. Produced from this, you're going to get potassium acetate, which is a soluble salt, so we will separate it into ions. And this acidic hydrogen right here, plus that hydroxide, gives us some water. Potassiums are spectators, they cross out. So you're left with OH, acetic acid, the acetate ion, and water. Check for balance, and not only check for mass balance, like to make sure your elements are the same on each side, but you got to also check for charge balance. Once we get into redox reactions, that's going to become pretty important as to making sure that charge is balanced as well. All right, calcium hydrogen carbonate solid is added to an aqueous solution of acetic acid. Formula for calcium hydrogen carbonate, CaHCO3 Solution of acetic acid is weak, so CH3COOH. We keep it all together. This one's solid, so we keep him together. Reactant, you see that right here we have a carbonate, so that tells you you're going to make carbon dioxide gas. Whoa, getting stuck here. Carbon dioxide gas. Oh, come on. Stuck. We also know that we're going to have a salt, and it's going to be the cation of our basic compound, the anion of our acidic compound. Calcium acetate is soluble, so we're going to write them separate. Calcium acetate. And then the other product is water. From here, we can cross out our spectator ions, but if you notice, we don't have any ions on the reactant side, so we have nothing to cancel out. So all we have to do is make sure this little guy's balanced. So one calcium here, one calcium here. I have two hydrogens here, plus the one that I have over here gives me 3. And I come over here, I have 2 hydrogens right here. So I got an odd number here and an even number here. So let's take my guy that's making me odd, my single hydrogen right here. Plop a 2 out in front of him. So now I have 4 hydrogens. I'm not counting this one because I'm going to treat this CH3COO as a polyatomic ion. So I have 2 hydrogens here. 2 hydrogens here gives me 4. If I put a 2 there, now I have 4 hydrogens. Moving on, I have 2 carbons. I only have 1 carbon right here, so I'm going to put a 2 right there. Again, I'm not counting this carbon or this one because I'm going to treat this CH3COO as its own entity, really, as its own polyatomic ion. So now I'm going to move on to my oxygens. I have 6 oxygens right here. I have 4 oxygens here, plus 2 more gives me 6. Now I'm going to move on to my acetate ion. I have 2 acetates. I only have 1 here, so let me put a 2 out front there, and that made me balanced. Okay, aqueous nitric acid. Nitric acid is one of your strong acids, so we're going to go ahead and ionize that guy. Reacts with solid lithium sulfide. Lithium, I don't know why I put that there. Lithium sulfite. I see sulfite, so that tells me that one of my products, sulfur dioxide. Then the other one, this lithium is going to react with this nitrate, sort of, to make lithium nitrate, which is soluble. So I'm going to go lithium plus, nitrate minus. And then my other product is water. Balance this guy out. I got 1 hydrogen. I got 2 hydrogens. So I'm going to go, oh wait, I can cross out my nitrates. Bam. 2 hydrogens there. I got 2 lithiums. I only got 1, so let me put a 2 right there. I got 1 S, I got 1 S, I got 3 O's, I got 2, 3 O's, so we are good. And that, ladies and gents, let me go ahead and write this guy out. 2 hydrogen ions plus the lithium sulfite, 3, gives me sulfur dioxide plus 2 lithium ions and some water. I'm going to have to get the rest of these example problems done on a part 2.